Hello everyone, my name is embarked. So today, me and my teammates will discuss about our final project for course as ICT501. And this project, we have interviewed POSHSTOP as our selected company, which is a clothing business. So firstly, I will introduce my teammates. First, we have Putri Nur Zulaika binti Nur Rizwan. Next, we have Nur Najwa Aina binti Muhammad Nazri. Next, Ahmad Tajuddin bin Amran. Next, Muhammad Amirul Nizam bin Ahmad Sai. And the last one is Nur Adina binti Muhammad Saha. We have 11 points that we will discuss. First, we have company background, problem statement, objective, business rules, PRD, 3NF, flowchart, data definition language, DDL. Then we will move to data manipulation language, DML. Next is demonstration structure query language. And the last one, we will talk about demonstration of database system. Next, let's move on how they collect and store data. So basically, POSHSTOP company has been using ordering system as their platform to collect and store their company data. So what is the process? So the first process is POSHSTOP Instagram page will be viewed by the customer. Next process, the customer examines each item individually before making a decision. Next process, the customer will contact the owner via Instagram message to reserve an order. Next, the owner will send the bank details. Next, the customer has only 15 to 20 minutes to send the proof of payment. Next, Google form will be sent to the customer so that they can fill out their data. Next, on Excel, the owner will store the data and will keep on track of all transactions and customers' data. And the last process is the owner will ship the packages out and provide the customer with tracking number. And for your information, they only use Excel to store data. And I think by using Excel, it is very inconvenient for a company like POSHSTOP to store their data because their data is enormous, so it is impossible to use Excel as their platform to store and collect data. What is POSHSTOP? POSHSTOP is a Kuala Lumpur-based online clothing store. It was founded by two independent young ladies, Mira Elia and her friend, but the company later branched out, and Mira Elia is now the sole owner. Furthermore, the 2-year-old company has been relatively popular with teenagers and adults between the ages of 17 to 30. The idea for this online store came about while they were thrifting at a bundle store and realized they could profit from it. On top of it, they have been using Google Forms and Microsoft Excel to implement a simple order system for customers to purchase their desired item, and they still don't have a proper database system to store their company data. Now, let's talk about problem statement. First, customer is unaware of the item's availability. Next, the customer still use a physical receipt for each order, which they must write by hand. Next, transaction issues. Next, in the manual system, mistakes are unavoidable because processes are manned by error-prone humans. Let's move to our objective. First, we want to provide a database system that is more reliable, fast, and organized. Next, we want to deliver a high-quality system that provides a proper and user-friendly database system. Next, we want to establish a systematic system that helps our stakeholders manage better transaction tracking. Fourth, to develop a customer-friendly and accessible platform for ordering items. And the last objective is to create a system that is able to keep track of inventory and supplies. That's all from me. Thank you.
Hi, my name is Muhammad Amir Nizam and I will proceed with business rule. The first one is each customer can make one or multiple order while each order can only be made by one customer. Secondly, each order will generate only one payment and each payment has to be made for each order. The third one is each order can have many items and each item can only be included in many order. Next, each payment will be received by one employee and one employee may receive many payment. Finally, each employee can handle many order but each order can only be updated by one employee.
Hi, my name is Adrina and I'll continue with 3 and F relational schema. For the first stop, we have table name customer, where we have 5 attributes and our primary key is customer ID. Next, our table name employee, where we put our employee ID as our primary key and this table has 5 attributes. Next, we have table name order, where order ID is our primary key and whereas employee ID, customer ID and payment ID is the foreign keys. Next, table payment, where payment ID is our primary key and we have item ID as well as order ID as our foreign keys. Moving on, we have table name item, where this table has 5 attributes. Our primary key is item ID and our foreign key is payment ID. Then we have item order, which is our bridge entity. This table has 2 foreign key and primary key at the same time, which is order ID and item ID.
For the flowchart, first the employee will log in into the system and they will view the dashboard. Then they are able to manage employee salary, customer, stocks and report. After viewing the dashboard, managing the employee and customer, employee can log out from the system.
This is the data dictionary for our database. First, we have table customer with 5 different attributes: customer ID, customer first name, customer last name, customer PIN number, and customer address. And the data types are as follows. Then next, we have table employee with 5 different data types, which are employee ID, employee name, employee phone number, employee username, employee password. And the data types are number and varchar too. Next, we have salary employee table with 2 attributes, employee ID and employee salary. They both respectively have number and decimal data types. Employee ID is primary key. Hourly employee has 2 different attributes, which are employee ID and employee rate. And the fifth higher table would be item table with 4 different attributes: item ID, item name, item price, and item stock, with the data types are as follows. Next, for table payment, it has 4 different attributes: payment ID, proof of payment, item ID, and order ID. Payment ID is a primary key. Whereas we have table order with 6 different attributes: order ID, order quantity, order date, employee ID, customer ID, and payment ID, with the respective data types as well. Moving on, for our last table, we have item order with order ID and item ID as its attributes, and they both are number data types. We will now move on to the data definition language, where the first type we create customer tables. Customer table have 5 different attributes that we created: ID, first name, last name, PIN number, and address. And they are of number and varchar 2 data types. None of these could be null values, and the primary key is customer ID. The output of the table is as below. Next, we create employee table with employee ID, employee blah blah blah. Next, we create employee table with employee ID, employee name, employee phone number, employee username, employee password, where employee ID is our primary key and it cannot be a null value. It is a number data type and the rest are varchar 2 data type. And the table is as below. We also created salary employee table with employee ID, employee salary as its attributes, where employee ID cannot be null and it is the primary key. Also, we created hourly employee table where employee ID and employee rate are its attributes. Employee ID is a number data type and employee rate as a decimal data type, where employee ID cannot be null and is a primary key. Creating item table, we have 4 attributes: item ID, name, price, and stock, where they are of number and varchar 2 data types, and item ID are its primary key. Syntax for creating payment table, having payment ID, proof of payment, item ID, and order ID as its attributes. They are of number and varchar 2 data types, and the output in SQL are as below. We also created order table, where it has 6 different attributes: order ID, order quantity, order date, as well as foreign keys, which are employee ID, customer ID, and payment ID. And the output in SQL as a table are as shown. Next, item order table. We have 2 attributes, which are order ID and item ID, which are both number data types, and the syntax are as below, whereas the SQL equivalent of the table are shown.
In conclusion, the system can store and organize customers' data, purchase records, and the transaction documentation. It may also replace the use of manual data storage processes such as paper documents. The system also helps our stakeholders manage better transaction tracking and enhance data integrity and reduce any data redundancy. Finally, the system can help to keep track the inventory and supplies.